Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. I will now be continuing my long video format lecture on analytic geometry. For tonight, I will be discussing analytic geometry lesson number 4. And the title of the topic is actually how to find the equation of straight line. Oh, this is a long video format. Okay, let's proceed. The subject matter for tonight will be analytic geometry, lesson number 4. And the title of the topic will be how to find the equation of straight line. One of the most interesting problems under the study of analytic geometry is in the so-called finding of the equation of a curve or a straight line. For the meantime, we are considering straight line. So it is not what they call this. It is much more easier than for a curve, because later on we will go for the equation of a curve. That's another topic. So for tonight, we will be discussing on how to compute for the equation of a straight line. There are 3 variations in the so-called computation of a straight line. Okay, I will try to discuss the 3 variations. But since we have a limited magnetic world, I will just discuss the first 2, and the next time around, I will be discussing the third one. Okay, the 2 cases of variation of problems on how to compute the equation of a straight line. There are 3 cases actually. Case number 1, 2, and case number 3. For case number 1, there should be what they call this some parameters given for it to fall under case number 1. And for case number 1, we are given 2 points. Meaning, if we are given a straight line, we are given 2 points on the straight line. Meaning to say, if we are given 2 points, the abscissa and ordinate are actually given. Okay? So this will be point number 1 and point number 2. Okay, if we are given the coordinates of this, okay, the problem is asking what will be the equation of the required straight line. Meaning to say, the straight line passes through these 2 points here, P1 and P2. That is case number 1. Case number 2, we are given the slope and the so-called y-intercept. We are given the slope and the y-intercept. So meaning to say, we are given m and we are given the slope. And the problem is asking what will be the equation of the straight line. Case number 3, in which we will not discuss for tonight, that will be our next lesson. Case number 3 will be given, we are given a point and a slope. Meaning to say, we are given a point on the straight line, and we are given the slope. Okay, so we are given 1 point on the straight line, and we are given the slope. So the problem is asking what will be the required equation. That's case number 3. We will be discussing that one the next time around. Okay, let's proceed with case number 1. For case number 1, I will try to bring out figure number 1. So case number 1, figure number 1. Okay, so this will be the y-axis, x-axis. For case number 1, we are given P1. The coordinates will be x1 and y1. We are given P2, and the coordinates will be x02, y02. And we will take an intermediate point on the straight line. You could take any location you want. You could take the location to be point P, to be in between P2 and P1. Right? So I will place it here. This is point P. This is with coordinates xy. The coordinates xy, because we will be expressing our answer in terms of x and y. So if we try to solve the equation, it will be in terms of x and y without any subscript. Okay? So the intermediate point will be point P and the coordinates will be x and y. Okay, let's try to bring out the derivation on how to compute for the required equation. Oh, this is just a simple one. For the derivation of the equation, we are given 2 points, right? So if we are given 2 points, we could compute for the slope, right? This is point P1, this is point P2. So actually, we could compute for the slope. Okay? We are given the coordinates of this. So we could compute for the slope. It will be the ratio of the opposite side over the adjacent side. And actually, it is in general. That's why we pass by, I think, lesson number 2. The computation of the slope. The formula on how to compute for the slope is actually the difference in ordinates over the difference in abscissas. So if we are considering point P21, this will be the formula. Right? That's the formula. We are given y sub 2, we are given y sub 1, we are given x sub 2, we are given x sub 1. See, so this is actually a pure constant. Right? But for the meantime, since we are not given the value of the ordinates in abscissas, we will just write it as just simply the difference of y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay? Considering point P and P1. Point P is actually our intermediate point. And the coordinates will be xy. And for point P1, I consider point P1. It will be, the coordinates will be x1 and y1. So again, considering P and point P1, again by using this formula, it will be the difference in ordinates over the difference in abscissa. So considering P and P1, slope still will be the difference y minus y sub 1 over x minus x sub 1. This y here is without any subscript already because we would like to express our answer in terms of x and y. Right? And this x here is without any subscript. And since we are considering the second point to be P1, there is a subscript 1 here and this is subscript x sub 1. Okay, but the first y here is without any subscript because we would like to express our answer without any subscript. Okay, so by considering P and P1, this will be the formula on how to compute for the slope. That is y minus y sub 1 over x minus x sub 1. Okay, equating slope is equal to slope. That's algebra. First one, the difference of y2 minus y1 over x2 minus x1. And this should be equal to y minus y sub 1, considering equation number 2 over x minus x sub 1. So if we try to compute for y here, we are always expressing our answer in terms of y equal to a function of x. Okay? The resulting equation now, for the final equation of the straight line, if we are given point P1 and P2, it will be, this is y minus y sub 1, right? So we will transpose this x minus x sub 1 to the left. Then we'll try to rearrange it. But if we try to compute for y, this will go to the left, right? Then we try to rearrange. So therefore, y now, okay, will be equal to y sub 1 times the product of y sub 2 minus y sub 1 over x sub 2 minus x sub 1 times the quantity. This will go to the left. We rearrange, right? Times the quantity x minus x sub 1. And this will be the required equation. Okay? For the resulting equation, this y sub 1 is given, y sub 2 is given, x sub 2 is given, x sub 1 is given, x sub 1 is given. So our answer is just in terms of y equal to a function of x. In terms of x and y without any subscript. Okay? So this is the equation of the required straight line if we are given point P1 and P2. Right? This is the required equation. You don't have to memorize this one, right? Actually, you could derive this one by just knowing the equation on how to compute for slope. Okay, for case number 2, Case number 2, we are given the slope and the y-intercept. So if we try to bring out case number 2, right? So this will become figure number 2. This is the y-axis, this is the x-axis, this is the straight line. We are given the y-intercept. Y-intercept, we discussed that one the last time around. It is actually a point on the y-axis where the straight line passes. And this point here is actually with the coordinate 0. You have c is 0, and the ordinate will be small letter b. Okay? We are given the y-intercept. What's the other given? The slope. The slope of the straight line with respect to the horizontal is actually designated by small letter m, and this is actually given. Okay, let's try to bring out the derivation. Am I still on camera? For the derivation, we will be starting with the definition of slope. Still, slope in general will be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If you are considering point P2 and point P1. But by following this one, if we try to consider point P with coordinates xy, what is point P? Point P is actually an intermediate point on the straight line because we would like to express our answer in terms of x and y. So the coordinates of these are actually in terms of x and y without any subscript. Okay? So consider point P with coordinates xy, the intermediate point, and P1 will designate the y-intercept to be point P1. And the coordinates are actually 0, the abscissa is 0. Okay? And the ordinate is small letter b. So considering point P and P1, and by using this formula, the slope now will be equal to y, the ordinate of the intermediate point, minus the ordinate of point P1, which actually coincides with the y-intercept. It should be minus b over x. Okay, the abscissa of the intermediate point P1 is actually 0. So m is actually, by using this formula, considering P and P1, it should be y minus b over x minus 0. But this is not 0. Right? So y minus b is equal to mx. Right? Therefore y now will be equal to mx. We'll transpose this to the left and we try to rearrange. Y now will be equal to mx. This negative, right? We put it on the left, then we try to rearrange. This is plus b. So the required equation, if we are given the slope and the y-intercept, this is the required equation. That is y equal to mx plus b. Case number 3, we will discuss that one the next time around, so we'll be in the so-called systematic form, okay? We are not rushing. We are taking it gradually, you know. So for tonight, that's the way on how to compute for the equation of a straight line. Case number 1, if we are given 2 points on the straight line. And case number 2, we are given the slope and the y-intercept is given. Okay, for those of you who would like to subscribe or watch my channel is at youtube.com/@ProfDVJ If you want to share it, please click share. For those who are not yet watching my long video format, just to tell you, I have uploaded 8 subjects already. It's on the so-called long video format. It's a complete syllabus, right? And this is actually this 9 or 8 subject matter, right? So if you want to learn the subject matter, differential calculus, integral, differential equation, advanced math, AC circuit, AC machines, algebra and trigonometry, you can watch my channel. My channel is at youtube.com/@ProfDVJ. Okay, good evening from Los Angeles.